Gil has a PhD, ABD in applied math at the University of Waterloo. He's the founder and CEO of Xtropic, which is creating thermodynamic chips, and is co-founder and theme lord of Effective Acceleration. Cool. So going to do more of a fireside chat, and then open again into questions from the audience. We'll focus this particular one on the theme of the event, democratizing intelligence in the broader AI and computer landscape. Would you like to give any opening remarks?
Yeah, I mean, the thesis of, EAC is essentially a thesis about how civilization evolves over time, how every piece of information from memes, cultures, technologies, ways to organize ourselves, genetics, everything is getting selected for its ability to confer whatever its host is, your ability to grow. And fundamentally, the EAC prescription is more of a hyperparameter prescription rather than a parameter prescription. So what I mean by that is that where EAC doesn't tell you how to live your life, it just sets up the hyperparameters for there to be competition across various dimensions. And so there, freedom is paramount and embracing variance. And that means, for example, for AI and compute, embracing variance across every assumption. So embracing variance across substrates. I work on that during my day job, right? So, what's beyond GPUs, but also embracing a variance of models, right? So we don't want there to be only, very low entropy distribution of the models that only like 5 labs are allowed to explore. We want there to be freedom to explore the hyperparameter space of models, right? Why do we want variance and why do we want freedom? Well, if you view this sort of adaptation algorithm like a genetic algorithm, there's fundamental theorems of evolution, Ronald Fisher, to tell you that the speed at which we progress is sort of bounded by the variance, right? The more you colloquially, the more you fuck around, the more you find out, right? And so, really, what we fight for, sort of actively, is just maintaining freedom, maintaining free markets, maintaining the ability to compete, maintaining the ability to disrupt, right? Because times there are changing, right? Clearly. And instead of saying, okay, we have anxiety about the future because there's a high entropy over future paths, let's kill the entropy, let's legislate and constrain everything, right? So now we have a good predictive model of the future. It's actually, let's maintain adaptability, let's maintain variance, let's maintain plasticity, how we do everything so that we can adapt quickly whatever quick changes come, right? So effective acceleration is embracing this acceleration process, embracing this sort of adaptation of everything and leading into it. In fact, it is a sort of generative process from which everything that is good that we know comes from, right? The beautiful technologies, beautiful pieces of art, beautiful humans, biology comes from this process. We want to keep this process going. We don't know what's ahead necessarily. We just know that we want to maintain adaptability because complex systems that become stiff, that sort of sharpen their prior and stiffen their priors across variables, they get disrupted. And it's a catastrophic failure. So we want to encourage plasticity. And, there's a lot of fear-mongering right now with compute, with AI. The future's uncertain. Let's kill the variance. Let's over-legislate. We're leaving a lot of upside on the table. So, hopefully today we can have a discussion about how do we maintain a sort of beautiful, adaptive, free market with the space of AI and models and compute. And, hopefully we can start a good discussion.
How do you think about maintaining a balance between societal robustness and freedom and individual agency?
Yeah, I mean, it's always a question, right? That's a hyperparameter prescription of how much malleability you want to maintain. Well, if you have a very high uncertainty over the fitness landscape, you should have very sort of higher entropy allowance, right? And so we don't know what the future looks like, right? We don't know. Well, I think my personal thesis is that transformers and GPUs are absolutely not the end of the story. We should stay open-minded, right? We shouldn't legislate hard code legislations, right? It's like hard coding, your code base. It's never great. You want to keep things parametric. Like we don't want to hard code too early. Everything for the current incumbents, the current paradigm. Want to stay malleable. So yeah, there is a sort of openness hyperparameter, plasticity hyperparameter we want to tune, but clearly it's not the zero setting, right? And so it's all about balance, and I think that political landscapes and algorithmic amplified landscapes, things converge to bimodal distributions of bands, and I think EAC is the counter move to say that AI doomers and shut it all down sort of narrative. And so hopefully discussions like today and discussions like we actively have online help us converge on the right balance between being techno-conservative or sort of entropy avoiding versus entropy seeking, open-minded pro-acceleration. So,
yeah. One question I wanted to add is, so I know you favor adaptability. Pragmatically, you're running a company, Extropic. Do you see there being any core assumptions or truths that you're believing in over the next 10 years that this specific project is based on? Call them eigenvectors of Extropic. And how would you choose those in lieu of your core philosophy being around adaptability and you're playing in a very ambiguous space?
So, let's say so if legislation against compute is a certain immunity to particular sort of, imagine something analogous to genetic code in the space of technologies, right? Let's say then GPUs of XYZ spec, right? What would a virus do, right? It would mutate around this immunity and sort of spread, have higher entropy of the genetic space. So what I'm doing is starting a Cambrian explosion over the space of hardware, right? What we're going to do, and what I'm announcing later today, is that we're going to open source the concept of the Riemann computing, the whole stack, how to do generative AI as physics, right? You can have it in many substrates. We're going to open source how we do in superconductors. That's a general concept that you can do mechanical oscillators out of freaking probably puddles of water. I don't know, there's a bunch of stuff you can do, but essentially, if they try to ban one substrate, the system will adapt. And there's too much upside to viewing intelligence as matter. And so to me, I want us to embrace the variance of the space of hardware. So that's what we're trying to do with this Extropic. Of course, we're going to have one thesis that we scale, right, and silicon. But yeah, overall, I think there's too many hard-coded assumptions about how we do AI today, right? I think people are exploring variance into the space of models, but the thing doesn't change. And something, for example, Zerchats is working on. Everybody's using NVIDIA GPUs all day, every day, right? And we're here trying to go to 1 bit of entropy in terms of providers to A and B, and that's already a struggle, right? So hopefully, we can start sort of the sort of Cambrian explosion of hardware substrates. And so I think in general, positive sum-minded. I want more people in the space, and so to me, I think intelligence is thermodynamics in disguise. It's a bold statement. I think I can back that. I think it's going to become very evident over time. And essentially, we're embedding intelligence into the thermodynamic physics of particular substrates. We're open sourcing that concept. There's a lot of overlap between the mathematics there and the mathematics of complex adaptive system that govern our world, right? Of course, systems that are complex and universal, you can embed the dynamics of one complex system into the dynamics of another. That's what we did, for example, quantum computing, right? We map quantum complex systems to quantum static complex systems. And so hopefully, with this sort of more lifelike, bottom-up divergent form of computing, we're going to be able to understand much more complex systems using far more compute, far more energy efficiently, right? And so it's not just, AI isn't just about trying to see the patterns of these complex systems that are adapting over time everywhere around us, but also how do we engineer them? How do we engineer policies to steer them in the right direction, right? They have some way to steer it. So yeah, that's basically what we're trying to do with Extropic, how it overlaps with With EAC, I think there's a lot of conceptual overlap, but they're separate things. Like for me, Beff was like this alt account, I tweet on at night. I was building dynamic computers. I was in the mind space, but I got doxxed, and now my identities are merged, so I'm going with it. But they're secret things.
How have your views changed over the last 2 years?
That's an interesting question. Yeah, I think I've come to appreciate biology far more. Biology is a thermodynamic sort of self-adaptive algorithm. It's an optimization algorithm running at all times, and it's had a lot of compute in pre-training. It's had billions of years of pre-training, and so there's a lot there. Right? There's a lot there. We can take inspiration from biology, but creating synthetic systems that throw as much compute into optimization, it's pretty costly. So basically, I've been more merge pilled. I think there was an event earlier today on augmenting human intelligence. I think the highest likelihood path is that we have a sort of smooth merge where we have agents that share our perceptions and suggest actions, and in a sense, if they have the same perception and action states, according to theory, have the same Markov point, you do the same agent. I think that's a way to have a smooth merge. Think of it as like an executive assistant that's shadowing you all the time, right? You communicate with it very efficiently prior to where your actions are, your intents are information on recent states. To me, I think we're heading towards a smooth merge. You're seeing with all these variables. What I really want in the future is, for your humane to connect to your, tiny core, tiny box, or your Astropic box someday, and you have personalized compute that's an extension of yourself, it's an extension of your intelligence, right? Because if we're going to have a soft merge where we give first and more intelligence to the model that's an extension of our cognition, it better be personalized. Because right now, if we all give our intelligence to one global amortized model, then we are bored. Right? We have lost our individuality. So there's a lot of power in shaping the priors of that neural network because you're literally controlling people and their thoughts in the shadows, right? And so it's really important that we have freedom of compute, freedom to own compute, freedom to run our own AI, because if we are to have smooth merge, we need to be in control of extensions of our own cognition to maintain individuality. And I hopefully don't have to explain why individuality is important.
I think we can have time for one question from the audience. Then we'll move on.
So I'm an aerospace guy. I'm going to do the thing, economic physics. You're one of the few guys that I see talk about statistical mechanics, thermodynamics, information theory. How important do you think that is to block AI? Do people really study that?
They should. I think so. My background originally I was a theoretical physicist working on theories for everything, trying to view the whole universe through the lens of information theory. I think there's nothing you can see through the lens of information theory. Machine learning really is an operationalization of information theory. Information theory is all about entropies, entropies of conditional distributions, entropies of channels, entropies of mutual informations, et cetera. But ultimately, AI is like learning. You're searching over the space of codes, right? Shannon tells you there exists a code, right? There exists an entropy, there exists a compression code, right? The AI finds that and searches over the space of transformations to find approximately a good code to achieve entropy, right? What our transformers are doing, they're minimizing cross entropy, and the reason all foundation models converge to the same performance is that they're all converging towards the entropy of the distribution. Some people leave that matter. And so if people really understood the information theory better, I think we'd be better off in terms of guiding progress in AI. But I think it's definitely harder to learn than importing libraries and so on. But to me, thermodynamics, right, is a bridge between information theory and physics. Right? You have entropies appear very naturally. free energies, right? And so you can imagine the way we're doing our analog computing, analog computing, analog, right, or like analogous, right? So we're instantiating the analogy between information theory and machine learning through bridge to thermodynamics. And so essentially, it's like you go from machine learning to information theoretic graph, and you map that to a physical system and support radiation, right? And so very few people think like that. It takes a weird mix of backgrounds, but I think it's going to eat the world. Frankly, I think this sort of thinking hopefully is a whole new school of thought that will sweep through every facet of our lives. That's a very bold statement, but I think once your free energy principle filled, you get into active inference and so on, you start seeing it everywhere. It's hard to unsee, right? I think that we can be bold and say that like this school of thought progressively taking over is going to be as big of a revolution as like Newtonian mechanics was to our understanding of the universe, right? It's like starting to understand complex systems, starting to understand intelligence, starting to see intelligence and all sorts of systems that are around us in our own biology, our markets, etc., and then being able to steer it and accelerate it. And that's basically what FIAC was his first step towards that. Hopefully there's many more institutions and movements that spur from this wave that's coming. Cool.
Thank you, Gil.
Thanks.